Last night you finished a chart in Python and the leftover plot already told the truth. Monday morning, operations wants that same picture on a wall they can refresh. They will not open a Jupyter notebook just to see the answer. The model lives in Python. The wall they open is Power BI. Tonight I will teach that connection the way I would sit beside you at a desk. We type each important line together. Then we carry the same idea into Power BI. Our story is small on purpose. A night food court called Lantern Market. Stalls sell tickets after dark. Rain comes and goes. Hours matter. You already know pandas. Power BI already knows the rest of the company. Our job is the bridge between pandas and the wall, not a prettier slide. Microsoft gives Python 3 different jobs inside Power BI desktop. If you mix those jobs up, Friday refresh is the thing that breaks. First job, get data. A Python script becomes a table in the model. That table can feed ordinary bars, slices, and cards. Second job, Power Query. A Python script shapes a table that already arrived. That is where you add a flag the rest of the report can slice. Third job, a Python visual. Matplotlib paints a picture on the page. Those are 3 tools, not 3 names for the same click. We will open them in that order with one table so you can feel the difference. Why open Python at all if native visuals are already good? Native visuals are excellent for bars, slices, and cards people already trust. They are not the heat map you already live in or a leftover scatter from a model. When Pandas already draws the picture, Power BI can stamp that same picture. I want you to hear Microsoft's own sentence, not a slide I invented. On Microsoft Learn, they say you can run Python scripts inside Power BI desktop. From that model, you build reports and you can share them on the Power BI service. The same family of pages covers Python visuals and Python inside Power Query. Before any script, point Power BI at one Python and only one. Open Power BI desktop. Go to File, then Options and Settings, then Options. Under Global on the left, open Python scripting. Detected homes appear in a list. Pick the same Python your notebook uses. If conda fights you, prefer a plain install from the Python org site. A mismatch here is why a script runs in Jupyter and dies in getData. Open a terminal that belongs to that same Python. Install pandas because pandas carries tables in and out of Power BI. Install Matplotlib. That library draws the figure the visual will stamp. Install Seaborn if you want the heat map we will type later. Do not mix 2 Pythons. Power BI desktop will not guess which one you meant. Look at the table we will use. Keep it boring on purpose. Each row is one stall on one night at 1 hour. Tickets means how many sales landed in that hour and nothing else. Rain is 1 if it rained and 0 if it did not. We will add expected tickets, the usual count for that stall and hour, then leftover tickets minus expected. Hot means the stall beat its own habit. Power BI will not debug pandas for you. We prove the table in a notebook first. Open a Jupyter notebook. Name it Lantern Market Dry Run. Watch the first line appear as I type it. We import pandas. That loads pandas so later lines can read the data file and build columns. From Matplotlib, import path. Path is how we point at the file with a full path. Microsoft wants a full path. A short relative path can die inside get data. Set the path to the folder, then the file name Lantern Nights. Read that file with pandas. Call the table nights. Each row is now in memory stall night, hour, tickets, rain. Turn the night column into a real date, not a string that only looks like a date. Then make a weekday column from that date so Friday is computed, not typed. Group by stall and hour. Take the mean of tickets. Call it expected tickets. Reset the index so expected tickets is a proper table we can merge. Merge that back onto nights, matching stall and hour. Now every row knows its habit. Same stall, same hour. Average across nights. Leftover is tickets minus expected tickets. That difference is the residual. If leftover is positive, the stall ran hot. If negative, it ran quiet. Print the first rows. Confirm the new columns. No empty table. The name report is what Navigator will offer after getData runs. Save the notebook. You will not debug pandas inside Power BI. If the notebook is happy, this same script can travel into getData. Keep the script short. One table in, one table out. That is what refresh trusts. Read the limits in plain words before we paste anything into desktop. Only pandas data frames import. Nested objects do not. A script that runs longer than 30 minutes times out. Do not hide a training loop inside getData. Fit in the notebook first. In Power BI desktop, open getData from the home ribbon. Choose more than other than Python script from the list. A box opens. This is not a notebook. It is one script that must return tables. Paste the same script you already ran. Change nothing except the full path if needed. Click OK. Power BI now runs the script with the Python you picked. Navigator appears. You should see the report table with rows you recognize. Load it. Do not transform yet. We want the table in the model first. If privacy asks, public is the setting the cloud can actually refresh. Look at data view. Stall hour, tickets, expected tickets, leftover should all be there. You just used job 1. Python became a table. Native visuals can eat it now. Drop a clustered bar. Tickets by stall. This is ordinary Power BI. Add a weekday slicer. Click Friday. The bar should move. That is the point of getData. The company gets a model it already knows how to filter. Home transform data. You are in Power Query editor. Select the report query. Then transform run Python script. Power Query hands you a table named dataset. You do not read the file again. Watch this line type. We add hot night when leftover is greater than 8. That is a flag, not a chart. The rest of the report can slice on it. OK, check the preview. A new column should appear. Close and apply. Field should now show the hot night column. Use this door for columns. Use getData for the first table. Do not reverse them. Job 3 is a picture, not a table. Insert a Python visual on the page. Enable script visuals if Power BI asks. That is a safety switch, not a decoration. Drag hour, weekday, and tickets into values. The script can only see what you drag. The editor opens under the canvas. This sandbox does not share variables with getData. Microsoft stamps the picture at 72 dots per inch. Keep titles short. The script reads a table named dataset. Same idea as Power Query, new sandbox. Watch the first line type. Import Matplotlib pplot. That library is the stamp. Without it, Power BI has nothing to show. Next we import Seaborn because Seaborn will draw the heat map. Build a pivot table. Rows are hour, columns are weekday, values are tickets. The number in each cell is the mean, so one busy Friday does not own the color. Now draw a Seaborn heat map on that pivot so hour and weekday become color. Use a yellow, orange, brown color map and write the numbers in the cells. Give it a title you can read at a glance. Lantern market mean tickets. Call tight layout so labels survive when the image is small. The last line is plot show. That is the handoff to the canvas. Plot show is the handoff. Skip it and the canvas stays empty. Click run. You should see the heat map, not a gray error tile. If you see an error, click see details. Fix the script. Do not stare at the box. Add a second Python visual. Each visual is its own sandbox. Import Matplotlib pplot again. The first visual cannot share its imports. Make a figure and one axis so a scatter and a zero line can share the picture. Scatter expected tickets on the x-axis and leftover on the y-axis. X is the habit. Y is how far tonight wandered from that habit. Draw a dashed line at 0. Above it ran hot. Below it ran quiet. Label the axis, then call plot show, then click run. Put a weekday slicer beside both pictures. Click Friday. You did not press run that time. The filter changed the table and Power BI ran the scripts again. That is the automation. The wall updates when the filter changes. The picture is not a clickable chart. You cannot tap a cell to filter the page. Other visuals can highlight and the Python picture will redraw. The arrow does not reverse. Do not rename fields on the canvas and expect the script to follow. It still sees the original names you dragged into values. Desktop can run this. The Power BI service is stricter. Personal mode of the on-premises data gateway can refresh Python in the cloud. Forgot the gateway, and Monday refresh waits for you to open desktop. Public privacy matters if the cloud must run the script without you. Two tables have no relationship, the Python visual errors. The model still matters. A relative path that worked in Jupyter is the first thing getData will reject. Keep getData boring, assign data frames. A small head print is fine. Walk it once in this order so you do not invent a fourth door. Dry run in Jupyter, load with getData, shape in Power Query if you need a flag. Stamp the heat map with a Python visual, click a slicer, watch it redraw. Aim Power BI at one Python, install pandas and Matplotlib there. Full paths, public privacy if the cloud must run, a gateway if Monday cannot wait. 3 jobs, getData loads, Power Query shapes, the Python visual draws. Save the report as a Power BI file. That package holds the model, the scripts, and the page. Fit models in the notebook, score flag, and draw in the report. If Friday redraws the leftovers scatter on the wall, you did not make a slide, you handed the floor a kitchen.